In this lesson today, we are going to be talking about subtracting linear expressions. Okay, so what we're going to do is we are going to use what we learned about adding linear expressions to subtract linear expressions. And if you think about it, it's very similar to what we have been doing with integers since the beginning of the year. So just as a quick review, if we saw something like 6 minus 3, which we all know is 3, we could rewrite that problem as 6 plus a negative 3, right? We're adding the opposite. Either way, your answer is going to come out to 3. The same would be true if we had 7 minus 9. Now, the thing about subtraction is we can't change the order and flip anything around. So let's just rewrite the subtraction as addition. 7 plus the opposite of 9, which would be negative 9. And when you do that, you can switch this order around if it helps you to solve the problem. But either way, both of these equations will equal negative 2. Okay, so we are going to use the same idea with integers, and we're going to use it with expressions. So let's go ahead and do a quick review of adding expressions. So I'll give a simple example to get us started. So if we had 2x plus 3 plus 4x plus 5. These are two expressions, 2x plus 3 and 4x plus 5, and we are adding these expressions together. Since we are adding, we are happy about that because it's not going to change any of the signs of any of our terms. So we can actually just write this expression as 2x plus 3 plus 4x plus 5 and remove those parentheses. Now we just combine like terms. So we see we have a 2x here and we have a positive 4x here. Those can combine together to make 6x. And then the other like terms that we see is a positive 3, which is a constant, and a positive 5, which is another constant, and a positive 3 plus a positive 5 is positive 8. Okay. For those of you who like to do this vertically, line up your expressions. Remember, we would write 2x plus 3. And below it, just like lining up your place values, you have to line up your like terms. So 4x is going to go under the 2x, and 5 is going to go under the 3. You are adding these two expressions, so you will see that positive 3 plus positive 5 is a positive 8. Positive 2 plus a positive 4 is a positive 6x. Okay. Now, in this lesson, we are going to talk about subtracting expressions. So I'm going to go ahead and write an example out for us. Let's say we had 2x minus 9 minus 3x plus 2. So again, before we do anything to this expression, we see that we have an expression here and an expression here, and we are subtracting them this time. We are subtracting two expressions. So here's expression number 1, here's expression number 2, and what we are doing is subtracting them. So just like with integers and rational numbers, we don't want to work with subtraction. It gets tricky. So let's change this into an addition problem. Now, the way that you go about doing this is distributing that negative to the entire group of numbers inside the parentheses. So I am going to take 2x minus 9 and rewrite it because we don't have anything in front of the 2x minus 9 to distribute. Now this negative is going to get distributed into this group. So negative times 3x is a negative 3x. So we're going to be adding now because we distributed this negative to the negative 3x. Okay. We also have to distribute that negative to this positive 2. So see how we have a plus sign, and we have to also think about that as a positive. So a negative times a positive gives you a negative 2. So now that I've distributed this negative, or as we can see is also a minus sign, now we have 2x minus 9 plus negative 3x minus 2. And from here, we just combine like terms like we do with addition. So I see I have a positive 2x and a negative 3x. So when you add 2x and negative 3x, you just get negative x. Now, in front of that x is technically an invisible 1 because it's 1x, but we do not write the 1 because if we just have 1x, we just leave it as x. So negative x. And then the other like terms we see is a negative 9 and a negative 2. So see how I'm circling those subtraction signs to include them with the constant. So a negative 9 plus a negative 2 will give me negative 11. So our simplified expression here after subtracting would be negative x minus 11. Let me go ahead and show you how to do this vertically. You would go about the same process. You do want to distribute this negative first so that you're still adding, okay? So we're going to keep 2x minus 9 the same, but we distributed this negative. So now we have a negative 3x and we have a negative 2. What am I doing with these two expressions? I'm adding them, right? I'm adding them now because I distributed that negative. My like terms of negative 9 plus negative 2 would give me that negative 11. And 2x plus a negative 3x is going to give me that negative x. Okay, I'm going to go ahead and do one more example, and then I want you guys to try a couple on your own. So this example, let's say we have 6x plus 4 minus 2. And then in parentheses, we have a 3x minus 6. All right, so let's see what we're working with. We have one expression here. We have another expression here. And we're subtracting them. So we should already automatically be thinking to ourselves, okay, I need to distribute this negative so I can start adding. Now, the difference with this problem is there is a 2 that has to go with that negative. We have to distribute that 2 as well. So I'm going to go ahead and rewrite 6x plus 4 because there was nothing to distribute to that expression. And then negative 2 times a positive 3x is going to give me a negative 6x. So I'm adding now to a negative 6x. And negative 2 times a negative 6 would give me a positive 12. Now, I'm adding across the board here, so all I have to do is combine like terms. So I have a 6x and a negative 6x. And that right there is the additive inverse property, because when you have a positive and a negative of the same number, they cancel out. So you no longer have x's. They became 0. And then we have a positive 4 plus a positive 12, which would give us 16. Now, to see that vertically, for those of you who need it, you still have to distribute that negative 2, and then you would write 6x plus 4. Now we have a negative 6x plus 12. We are adding these two expressions. 4 plus 12 would give you 16, a positive 16. And like we said earlier, when you have a positive 6x and a negative 6x, they cancel out, so they become 0. So your answer is 16. I'm going to go ahead and do one more example. And then on our Google site, you will see that I included some practice on Khan Academy. And I believe it was some of your remote assignments as well to work with subtracting expressions. So let's go ahead and do, let's say 1/2. And we'll say 4x. Let's call this b. Let's use a different variable. Minus 3 minus e plus 7. All right, so a couple things happening here. We have an expression here and an expression here. We are subtracting these expressions, so we need to make sure we distribute that negative. Also, we have a half out here that we have to distribute to our first expression. Now, you all know how to multiply with fractions, so let's take that 1/2 and multiply it by 4b. Well, we know that 1/2 times 4 is equal to 4 over 2, which that is just equal to 2, right? So half of 4 is 2, so this becomes 2b. Now, 1/2 times a -3, so you would take 1/2 times, and 3 over 1. 1 times 3 is 3. 2 times 1 is 2, so 3/2. But it is negative, so this is going to stay -3 over 2. Now, we want to distribute this negative, remember, so we can add. So this negative comes to the b, so we now have a -b. And this negative comes to the 7, and because it's positive, it's going to turn negative. Now, all we need to do is combine like terms. So we've got a 2b, positive 2b, plus a negative b. So that's going to leave us with just b. Here we do have a -3/2 plus a -7. So since they're both negative, they're going to stay negative. And we actually know that 3/2 is the same as 1/1/2. So 1 plus 7 would be 8, so it's 8.5. So this is b minus 8.5, or we could say b minus 8.5.